Good day. Today we'll be focusing on the basic principles of isostasy. Well, if you're wondering what is isostasy, stay tuned for the next slide. Isostasy is a state of gravitational equilibrium in which an area of crust floats in a balanced way on the denser rock of the mantle below. The elevation of any part of the Earth's crust is a function of the thickness and density of the crust. For instance, the first picture there is a clear and simple example of what isostasy is. There is a container there, and the container it is filled with water. That water represents what is known as the mantle. So there is a brown object inside there. That brown object it is floating on the water because the object there it is less denser than the water inside the container. Here is the explanation of isostasy. Isostasy is the vertical movement of the crust to attain buoyancy in the mantle. The height of a block of wood floating in water depends on its density and thickness. The height of the Earth crust also depends on its density and thickness to float. The principle of isostasy states that parts of the crust will either rise or subside until these parts are buoyantly supported by their roots. Mountain ranges have thick roots of continental material that extend into the mantle. As mountains erode and mass becomes smaller, its roots will become smaller too. Balance between erosion and decrease in size of root will continue for 100 millions of years until both mountains and their roots disappear. The deflection of plumb bob near mountain chains is less than expected. Calculation shows that the actual deflection may be explained if the excess mass is cancelled by an equal mass deficiency at greater depth. Now let's take a look at the hypothesis of isostasy. The Pratt-isostasy states that mountain range supported by density variation within the crust. The Airy isostasy states that mountain range supported by changes in crustal thicknesses. Crustal density is relatively constant. Either way, the plate is relatively light and floats on the fluid layer beneath. Now we focus on the applications of isostasy. How isostasy is applied. The principle of isostasy states or suggests that the Earth's crust should adjust to any changes in mass that occur at the Earth's surface. We call these isostatic adjustments. There are basically two types of responses, the subsidence response and the rebound response. The subsidence response is the slow sinking of the Earth's crust, and it is caused by the addition of mass to the crust. And its examples include the advance of glacial ice sheets. The rebound response is the slow vertical rise in the Earth's crust, and it is caused by the removal of mass from the Earth's crust. For example, post-glacial rebound. It should also be noted that isostasy explains why continental plates cannot be subducted. The forces that drive subduction cannot overcome the buoyancy of these low-density plates. Subduction is a geological process that takes place at the convergent boundaries of tectonic plates, where one plate moves under another and it is forced to sink due to gravity into the mantle. Regions where this process occurs are known as the subduction zones. Isostatic adjustment today from load of glaciers on the crust during last glaciation and unloading from melting is called post-glacial rebound. The diagram below explains the process of post-glacial rebound. Feature A shows glacial forms adding weight to the crust. Feature B, it is whereby the crust subside due to weight of the ice. Feature C, it is whereby the ice melts, removing weight from the crust. Then the last feature D, it is the crustal rebound as the crust rises towards its original position.